And I just want to tell you a little bit about why we're doing this work. We've been playing around with legume green manure, so it's a different kind of cover crop. It's something that typically is just peas, not a mixture. We've been doing that since about 1999 and seeing some interesting results. The idea behind that was to trying to get the summer fallow a little bit more biologically active, get that soil cycling a little faster, and so we thought if we got some legumes going there, that might help. And boy, lots of different angles. We've looked at tillage, species, seeding rates, just about anything you can look at to try and make it work. And I will tell you that in the short term, most often it falls somewhere between a fallow crop and a recrop response. And that's if you're very diligent about terminating it at first bloom. And we've got some peas today, and I'm quite excited because these peas are just at first bloom yesterday and today. So if you want to see what peas at first bloom look like, that's the stage I'm looking for. We got lucky with that. We do have, though, we've had this one long-term study going on at Bozeman, and a couple of other studies are starting to get legs on them at Dutton and Big Sandy. And we're seeing some much more exciting results where we grow those legume manures every other year over a longer period of time. We are changing that soil, we are changing the nitrogen supply power, so we know if you can afford to stick with it in the long term, it looks like we can get that to work. But yeah, in the short term, if you just try it once and look for a response, sometimes you'll see something interesting, and sometimes it'll really probably just follow somewhere between a fallow and a recrop response. But there's been this interest in these cocktails now, the different species, and there's been a number of people that are responsible, I think, on the research end for getting that going. Jill Clapperton was one of the first people I know of that started talking about it. Martin Ants over at University of Manitoba, Gabe Brown at Bismarck. So there's a bunch of people that have been looking at this in other environments. And so we had a graduate student show up, it must be 3-4 years ago now, and looking for a project, interested in cover crops, and we decided to ask a simple question. And that question was, what can a mixed community of cover crops do that pea alone can't? And so we're looking at measuring specific soil properties, trying to actually measure, is there something that a community of different plants can do that just a sole crop of peas can't do? And we don't have an answer for you yet, but we're going to give you some data on that. Well, we're lucky enough to get a large SARE grant to let us pursue that, and so that's some of the research we're going to talk about behind us. So I already talked about the long-term aspect. I mean, I think if you can somehow figure out a way to stick with cover crops over a longer period of time, repeated cycles, I think you know, based on what we're seeing in our study in Bozeman, study in Swift Current, study up in Culbertson, yeah, you actually change that soil. It's actually pretty powerful what can go on, at least with a legume as a cover crop. We want to ask that question now with these mixed species also. And we know that this works in organic systems. I mean, they rely on cover crops, especially legumes, for their nitrogen source in organic systems. So now the idea behind this study was to grow cover crops twice in 3 years, and and that might be more often than a farmer would actually do it, but we wanted to sort of fast forward that response. If we grew it twice in 3 years, we were guessing maybe we'd see a change in some of the soil properties that we could actually measure by that 4th year after we've grown cover crops twice. You know, what are the theoretical advantages between mixed species and just sole species? There's an idea that we've got different functional groups in play. We might get more biomass, and I don't necessarily know that more biomass is a good thing. It would be in some situation, but if I grow a mixed community of species for 60 days, chances are I'm probably going to get more biomass out of that than if I pick any single species over that same time period. So if I want more biomass a given amount of time, I'll probably get it with a mixed species. And I think we've actually got some data down here that shows, yeah, we did. The first time we've run this, we did accomplish that. This one right here is the full mix treatment. So there's 8 different species in there, and then within we've broken that down in a number of different ways. So we've got our pea control in there. That's something that we've worked with for over 10 years. So we really want to see how these mixed treatments compare to something we know a little bit. There's something we have a track record with. With those 8 species, we've got we talk about different functional groups. We've got a taproot class, so you guys are all familiar with that. Turnips and radishes if you plant them late, not if you plant them early. If you plant them early, they really don't they don't make that exceptional of a taproot because they just flower right away. But they're, boy, nice and aggressive. So we got safflower and turnip as our two taproots in here. And the safflower is working really well. Turnip is not bad either if it gets a little space. And then brassicas is kind of a special class. In our case, we're trying to get some ground cover out of the brassicas, so we've got canola and radish as our two brassica crops. And the radish is the one that you see with all the white flowers behind this. It really gets up, it's a bigger seed, gets up, gets going fast, really vigorous plant. Fibrous roots, we've got, you see the oats kind of behind us in the second rep. That's a mixture of oats and canary seed. So if you haven't seen canary seed before, there's actually a pretty good presence of canary seed in there. We wanted to get two diverse different grass species in there. You get a chance to see what canary seed looks like. And then for nitrogen fixers, we've done a lot of work with the legumes already, and we've looked at different species, and pea is hard to beat as a nitrogen fixer. We've tried different species. We do have it mixed in there with lentil, and I think the pea, that plot there next to the Chem fallow is a mixture of peas and lentils, and you'll when you go look in there, you'll see their lentils are there, but they're just they're just not as vigorous as peas, and they don't fix nitrogen as well, and we wanted to have a little redundancy in each of these classes, so in case one of the species didn't grow, but it often tends that one does better than the other, and we'll talk about that more in a minute. So then we've got all these things set up where we grow the full mix and then pull out the nitrogen fixers, or pull out the taproots, pull out the brassicas. So we've got a number of different treatments there. So they end up being 6 species, and we're trying to see if pulling out that functional group changes those soil properties in some way. And of course we got Chem fallow in there as a control, and you can see that right there. Okay, so the first question I was supposed to ask you is, can cover crops be economical? Because that's something we get hit with a lot by producers. And I've got this graph on the bottom of page 2. It might take a little bit of explaining, but this is from a long-term study in Bozeman, and it's been a pretty cool opportunity because we've managed these systems. We've got wheat fallow systems compared to pea fallow systems, and we've managed them at 2 nitrogen rates, a full rate and a half rate, and we've also looked at protein premium response over a number of years. Analyzed it according to years where there was sharp protein responses versus flat protein. So we get a mix of responses between the 2,2N rates, between the 2 different protein responses. Long and short of it is the wheat fallow system falls apart when we start reducing nitrogen and dealing with sharp protein premium schedules. The pea fallow systems were really robust. If we remove that nitrogen, well, they still seem to respond with enough yield. They respond with enough nitrogen, and we save a little bit on the fertilizer that we're not applying. They respond well relative to protein. So that's anyways, it's been pretty exciting in the long term to see that yes, economically we can measure it, and it looks a lot better than just a straight wheat fallow system over the long term. That's after 3 cycles of pea manure when we started measuring that. But peas are pretty cold tolerant, and so we can get them in early. We want to get them in early so we can terminate them quicker. There's been a lot of work, there's been a lot of work done up in Swift Current by Bix Biederbeck years ago, looking at ideal growth periods with peas. Now I'm talking, nobody's done this work with mixtures. But this first bloom stage is really, that's the Goldilocks zone. If you let them grow longer than that, you might actually not be fixing any more nitrogen, and you're just using more water. And so we're really trading water for nitrogen, and so we're really trying to walk a tightrope with these things. I want to grow enough of them to get some nitrogen, to get some biological activity in that soil, but I don't want to use a bunch of water in the process. So that first bloom stage seems to be about, you go past that, you're walking off the gangplank. So that's what we're trying to avoid. And we actually do use some winter peas in Bozeman too, so that's not something we can use everywhere in Montana. Although I know Bob Quinn's had surprising success to me over at Big Sandy with winter peas, so I guess maybe it can be done in more places than I realize, but it has worked okay in Bozeman. When we get winter pea to survive, we get a really nice early growth response, lots of nitrogen fixation, but we still have trouble getting it to survive, even in Bozeman. We're going to talk about our results, but I wanted you to know there's other people doing work with cover crop mixtures. It's not just us. The earliest group I know of that really tackled it from a research perspective was the group at ARS Mandan, Mark Liebig and colleagues. So they've got a set of results there. I think their concluding statement would be is if you can have animals in the system, it's profitable based on what they've seen. If you don't have animals in the system, it's not really looked very positive for them. Now that's the difference there, or one of the differences there, is that they're looking at that post-harvest shoulder season. They're specifically looking in behind a pea crop, so something that's early matured, something where there's enough of a fall period to plant some cover crops, come in behind that, get some fall growth. And so that's different than what we're going to be looking at here. We're looking at a fallow replacement. But they're more with that Midwestern concept of having that post-harvest shoulder season concept. Looks good with animals. On its own, they haven't got it all published yet, and they're kind of reluctant to talk about it in any detail, but I had a chance to co-author a presentation with them, and that was sort of the punchline for the time being. So stay tuned on that. Darren Boss, maybe many of you know him in the big hat here back here. He's got an interesting study going on at Havre. He and Julia Defoe and Peggy Lamb. And so that's involving some different termination methods, chemical, mowing, grazing, and I think we're pretty excited about that to see how their results change with getting that animal component in there. And then at all of the research centers, they've got something going on with cover crops. So stay tuned. There's some work going on. We're looking at it. I'm going to ask the question: what cover crops were duds so far, and what are winners? Well, you can see one of the winners for sure. That white flowered radish. Boy, it's an aggressive, early growing kind of a plant. Puts on good biomass, can give you a little bit of a taproot even if it bolts. We'll talk about seeding date here in a minute, but if you really want to make a radish, you've got to wait till June to seed it. We're not very comfortable with that idea as a seeding date, but I am actually quite impressed with the kind of biomass it can put on. So it's getting right in there with peas. Pea has been another winner. Oat has been an interesting one. Oat is, one of the things I like about oat is there's a sawfly angle there. How lethal is oat to sawfly? Anybody know that one? What percentage? 100%. That's right. So it probably is more applicable when you can seed oat earlier, so it's timed better with that sawfly flight. But they like to lay eggs in oat, and it's 100% lethal. A lot of times they don't even hatch. I mean, it's that toxic to sawflies. So there's an interesting angle. There's another angle relative to the parasitoids too. The parasitoids need flowering plants. Right now they'd be very happy with these flowering radishes and other things that are going to start to bloom. So that can help with the sawfly angle also. The duds, we've tried Proso millet. I guess I better talk about seeding date to make sense of the millet. We tried seeding right first thing in April, thinking, man, we're going to get this seeded early. We're going to get it out by June 15th relative to the RMA fallow insurance guideline. Turns out the downy brome is really hard to manage with that early timing. You get still quite a bit of frost injury that'll take some of the plant species out. So we didn't get the kind of, at 2 sites, we didn't get the kind of establishment or weed control that we wanted with a really early planting. If we wait till June, you need some exceptional rainfall to really get that working. And some of these years, hey, it's been happening. A lot of years I've been in Montana, you wouldn't get anything, and I know Darren's had some experience at Havre with the later planting where they didn't get much. So we figured that Goldilocks zone for seeding is probably, and we've heard this from many producers, so that sort of affirms it. It's after your spring cash crops are already planted. You're probably not going to put this a higher priority ahead of spring wheat or spring peas or spring barley. You're probably going to want to plant your cash crops first. So we're now looking at an early May planting date. We thought that an early May planting date might be late enough to get millet going. It's a C4 plant, needs a little more heat. Turns out it still was too early for millet. So I think unless you're planting in June, forget about millet or any C4 grass, I would say. Annual ryegrass, that didn't work out very well for us. Camelina, surprisingly, didn't work out very well. It was very uncompetitive. Now that was at the early planting date, but in a mixed stand, it almost wasn't present. Vetch, we've had common vetch in here. Couldn't kill it with glyphosate. Couldn't even get it to stop flowering. I mean, usually with peas, at least I can get them to stop flowering with glyphosate. With vetch, anyways, tough plant. Didn't really do what we wanted to do because it continued growing and using water, and it was a little hard to manage.
And lentil just it's the seed can be cheaper sometimes, and it's easier to seed, maybe easier to seed through that residue, but it just doesn't have the nitrogen fix potential of peas. So we are exploring faba bean. There's some work going on. Canada's not doing much with cover crops, period, but they are looking at some legume green manures, and faba bean is one of the things that they're really excited about. So we're starting some work with that. It's supposed to be the biggest nitrogen fixer out there. We're doing some tests to see if that's really true in our environment or not. Seeding depth, we over-engineered this study the first time. We tried to put it in alternate rows with the small seeds in one row and the big seeds in another row, and then we hear from farmers that really they're just throwing it all down one row and hoping everything comes up. And so now we just go with a 1-inch seeding depth on everything, including turnip is a very small seed, pea is a very large seed. So that's probably too shallow for pea, too deep for turnip, and yet it seems to work. So we've actually I'm really pleased with the establishment we've had the last 2 years with this study. Seeding rate, we are going for 10 to 11 plants per square foot in total, and we're trying to keep the number of seeds even for all species. We don't, if you're seeding oats for grain, well, it's probably going to be 20 plants per square foot. If you're seeding turnip on its own, you're talking 5 or 6 plants per square foot to get ideal turnip production. We're just saying, no, we don't know. In a mixed community, we don't know really what the optimal seeding rate is, but let's get everybody a chance to play. Give everybody an equal chance, and so we're going with the same seeding rate in terms of numbers for everything. Of course, that works out to different pounds per acre, but we're trying to get the same number of seeds present for everything in a mix. So if you want to balance biomass, you got to start with a balanced seed mix. And I think we're doing at 10 to 11 plants. I know a lot of the seed mixes are coming out quite a bit higher than that. I'm real happy with the ground cover we're getting at that rate. Seed cost is ultimately is a big deal, so that's why we're trying to pay attention to that. And that's one of the things I like what Darren is doing at Havre. He's trying to use Montana-grown seeds mainly in his mixes to try and keep that seed cost down. Termination challenges, I guess I already alluded to that with the glyphosate. It's just hard to kill peas, it's hard to kill vetch, it's hard to kill some of the legumes with glyphosate. I don't even know if we're batting 50% on that. And so now Kent McVeigh over at Huntley turned us onto a product called Sharpen, which is at a 2-ounce rate, is about $11 an acre. And we've used it once already, and it just was it's a contact herbicide. 48 hours, your field is roasted. It's almost like Reglone or Gramoxone in that category. It's not in the same chemical family, but it's a non-selective contact herbicide, very instant response. So I think in all our studies going forward, we're just going to use Sharpen. We're done with waiting for things to die with glyphosate. As long as those plants, I don't care what color they are, if they're yellow or off green, they're still using water, and we want to shut that water down in a more timely fashion. I think this product will let us do that and let us do that affordably. I think at $11 an acre is probably worth it. I already talked about the biomass. I said, do you get more biomass with more species? Yes. And we compared, statistically, when we compared our 6 species mixes, we got 4 6-species mixes out here against 4 2-species mixes, and we get about a 10 to 15% greater biomass on average. And it's statistically significant. Is that a good thing? Maybe it's using more water. But if our goal is to produce biomass in a certain amount of time, maybe it's a good thing. Last year, did any of these cover crops use notably less water? We had a strange thing happen where our oat treatment, which was an oat millet treatment, which really meant it was just an oat treatment because the millet didn't grow, or it didn't amount to anything. It was actually had the least water use of both of our sites in 2013, and that's contrary to everything I know about plant growth. Cereals versus legumes. I just mentioned it because it happened at 2 sites in a row. And then this spring, it turns out that some of our very worst recrop on it has been on those same treatments. So something about them staying colder, wetter. I don't know if it's a denser vegetation on top where it's keeping it so. It's just a little bit puzzling for us. We're going to see if it happens again this year, but it was really curious that was the only one. Otherwise, we're seeing anything from no difference from chem fallow, if depending on with low biomass production, to something more in the 2 to 3 inch water use range relative to chem fallow if we measure right at termination. So we want to know exactly how much water has been used after after we've terminated that crop. Then you got winter recharge, and that tends to mute out that number over the winter. But it's usually in that 2 to 3 inch zone. So is that a number we can recover over winter? Certainly, it would absolutely depend on how much soil moisture you had to start with. And I alluded to one site where we saw no difference at chem fallow. Well, that was at Amsterdam in a record drought. Well, we didn't get any rain so the chem fallow was dry. It ended up being as dry as any of our cover crops. So. But if you've got, last year we had a really good moisture year, so it was a really good opportunity to measure that. And we did have some water use. Now, I'll get to the farm sites here in a minute. From what I'm seeing there, they're using even more water than what we're using in these plot studies. And so I think, you'll hear different people say water doesn't matter. Water matters. I think it matters a lot. So that's, back to that thing, termination time, I think matters quite a bit. Can we stop that at a midpoint and protect some of that deep soil water? I want to talk about the farm treatment. Well, I guess I should talk about this site, what we saw last year. So we didn't have a great run out of the chute with this site. We seeded early, got into some downy brome problems. We weren't able to keep all the treatments. But we were able to measure spring wheat under a real nice moisture year last year, and it turned out our best yield was on summer fallow in here. Our worst yields were in our legume treatments, our peas and our nitrogen fixers, which was a mixture of peas, and in that case peas and vetch. And at least part of that reason was we weren't able to kill the peas, and we certainly weren't able to kill the vetch with glyphosate. So even though we sprayed it, they continued to use water, and so I think that ended up being part of that story why we had significantly lower yields. 60 bushels on summer fallow versus 45 on these legume treatments. But again, that Roundup was a problem. How are the 2014 plot trials looking? We've got a site at Dutton on a heavier clay soil than this even, and we actually had to reseed that site. We did put it into winter wheat. Thought we had a good stand, came back this spring, and we've got 11 treatments in here, including the fallow. And at that Dutton site, only the fallow had an acceptable winter wheat stand. Actually looked pretty good. Any cover crop treatment was a bust. And so we had no choice but to reseed that thing. The worst were the oat treatments from the year before, but it was all bad, and so that's not really what I was looking for. And we had a similar thing happen at our site in Bozeman, at a very high moisture site, very high organic matter soil. Was surprised that again the fallow treatment looks so much better than any of the cover crop treatments. Why? We're still scratching our heads a little bit about that. It has something to do with being too cool and wet, and I think these things, they do keep the soil cooler and wetter at the surface. Well, winter wheat and early spring, that might not be a good thing. There may have been some temporary nitrogen tie-up. We know we had more saturated soils under those cover crop treatments first thing in the spring. That summer, that chem fallow was a little darker, warmed up a little sooner, and that seemed to matter quite a lot. We were able to keep the Bozeman site. It's a bit of a, it's recovering now, but the Dutton site we actually had to reseed. And I just looked at it last night, and again, I would have to say now reseeded to spring wheat late. The fallow still looks better. I mean, you got to. It's not night and day like it was before, but I would still say the fallow looks better than any of our cover crop treatments, and I would still say the oat stubble looks the worst. So that has carried over even with reseeding it. Answers, but I'm really looking for nitrogen supply. That's my big thing, and I've seen at least with legumes how we really truly change that nitrogen supply over time. And that has some impacts on how that crop grows. Because if I'm putting less nitrogen in at seeding and can rely more on the mineralization of that nitrogen during the actual growth period of that crop, that's going to time the water use better. Rather than just getting a real big whack of vegetative growth when I first apply that nitrogen, if I know I've got nitrogen in the soil, that if it rains, it's going to mineralize, it's going to feed that crop, it's going to protect the protein. To me, that's a real positive thing. So I want to get to where I can rely more on that soil nitrogen pool. That's the short answer. There's things relative to soil compaction. If I can get better infiltration, there may be some other things related to soil temperature. We're going to show you some data on that, and we're not really sure what. So there are other soil properties, and when are they going to be important? When are they going to be valuable? Ideally, I'd like to have that cover crop yield as much as my fallow. That would be my goal, and to do it in a way that actually protects yield and protects protein better than that fallow field will do it. Okay, I better finish up here. I just wanted to talk about the farm field comparisons. And last year we've got 6 on-farm sites, actually 7. Jim Bielen's site over here was close, so we added that one. Last year we measured the recrop yield on 2 of those. So all we do is we go out and measure water and soil nitrogen on one side of a field boundary where the cover crops were, and then we measure on the other side where the chem fallow was. We measure the soil, water, and nitrogen, and then we come back the next year and actually do replicated, randomized, small, little square meter samples. We might do a dozen of them on either side, randomized throughout each treatment in the chem fallow and in the. So we try and do it as statistically powerful as we can. We did a comparison here, and Herb and I were just talking about this. He left a skinny chem fallow strip for us to compare, and we went in and measured there, and then measured in a cover crop that he left longer on the east side of that field, and we measured an 18 bushel yield loss on that cover crop that was left longer. He had some stuff on the west side that he terminated sooner, and according to his yield maps, it actually looks better than the chem fallow strip. So again, it gets back to that termination timing and how you protect that water. If you let this stuff grow too long, I not to pick on Jim, but I know actually the camelina made seed in that cover crop over there last year. Well, camelina was actually his #1 weed this spring. That's letting it way too long. That's probably 3 weeks too long, and so it's using too much water. I'll keep harping on that message. Relative to and so we had another site at Dutton. We had an 8 bushel loss over there in spring wheat. Again, it looked like it was really water related, but also, we had a little bit lower protein, so there may have been some nitrogen tie up there too. But again, that's the first year after a cover crop. We often see a hit and miss kind of response that first year behind the cover crop. What do the current year sites look like? I looked at one at Fort Benton here that. The recrop side the cover crop side was burning up badly. You know the situation around Fort Benton in May. They really weren't getting any rain. Some of that winter wheat was really firing off. I've got great photos. That cover crop side looked horrible. I don't think it would have yielded half what the fallow did. Thankfully, it all got hailed out, so we'll never know now. But I've got some pictures that would suggest it would have been a bad deal in that situation. Again, I think that cover crop was left way too long the previous year. We've got Jim's situation over here where it was a pretty much to the line difference where the winter wheat did not survive as well in that cover crop as it did in the fallow. So he ended up spraying it out in his cover crop area and has replanted that to spring wheat. On average, we've been seeing an average of 4 inches of water use by termination on these on-farm sites. We have no control over that. We just go in and measure. And so I think that's too much water use. We've got to be back closer to that 2-inch number. If you're in that 4-inch number, pretty hard to recover from that, I think. And 66 pounds less nitrogen in the top 3 feet also. So we're using and tying up quite a bit of nitrogen. Again, that extra plant growth probably not helping there. So those are numbers we're concerned about. One of the challenges has been getting a balanced biomass response. And so with your seed mixes, you're trying to get, I think, roughly similar proportions of all crops. If you're going to have a mix, you might as well have a true mix. And you'll see that they tend to get dominated. The Fort Benton site was dominated by turnip, and this one was seeded really late. It was almost into June, so the Sudan grass did well there. The radish tends to be a dominant one. At Dutton, mustard and turnip ended up. I think turnip is a cheaper seed, so it's easier to throw more in the tank, and it's so small, why not throw more in the tank? So it ended up being pretty dominant there, along with yellow mustard. This site on Jim's was actually the best balance we've seen so far out of all the ones we've measured. It actually had a really good distribution among species. Pea and oat tended to be a bit more, but everything was present there, so it was really a nice distribution. Site at Great Falls, again, the turnip was, I'm not sure what happened there, but it was 70% of the biomass was all from turnip. So it's a challenge to try and get that right.